Type of errors may occur in languages. Compile time errors. When compiler errors occur, an error message is printed to the screen. All compile time errors must be fixed before a file can be downloaded to the board. Runtime errors. When a runtime error occurs, an error message is displayed on the LCD screen indicating the error number. If the board is hooked up with IC when the error occurs, a more verbose error message is printed on the terminal. Runtime problems. Runtime problems have various causes. System problems, expected error conditions, unexpected error conditions or bugs, normal conditions. System problems may cause running out of memory, failure to find a class or a method. The expected error condition may cause trying to open an unexisting disk file, trying to execute an invalid SQL statement. Unexpected error conditions or bugs may create trying to use a null object reference, trying to divide by 0. The normal conditions may occur when interrupting a blocked thread, trying to write to a locked database record. Exceptions. An exception is a condition that cannot be resolved within the context of the operation that caused it. Exceptions are runtime errors or generated errors. To throw an exception is to signal that such a condition has occurred. To catch an exception is to transfer control to an exception handling routine, alerting the normal execution flow of the program. Because exceptions are outside the normal operation of a program, the normal default action is to write out an error message and terminate the offending process. In which levels exception may occur? Hardware or operating system level. Arithmetic exceptions, memory access violations. Language level. Type conversion, bound violations, bad references. Program level. User-defined exceptions. Why exception handling? Exception handling catch errors before they occur. Deals with synchronous errors. Example, divide by 0. Does not deal with asynchronous errors. Examples, disk I/O completions, mouse clicks, use interrupt processing. Used when system can recover from error. Exception handler. Recovery procedure. Typically used when error dealt with in different place than where it occurred. Useful when program cannot recover but must shut down cleanly. Exception handling should not be used for program control. Not optimized, can harm program performance. The diagram on the page shows the hierarchy of Java classes representing the runtime error handling. Java.lang.throwable represents all objects that can be thrown. In other words, all runtime problems. Java.lang.error represents system problems. Subclasses represent specific problems such as out-of-memory error or virtual machine error. While these can be caught, usually there is little point, cannot do much about them. Java.lang.exception represents application problems. The vast majority of your problem handling code will address exceptions. This is why you will often see this technique called exception handling. Java.lang.runtime exception represents unanticipated exceptions. These can occur at any time, such as null pointer exceptions or arithmetic exceptions. While you can trap these exceptions, they generally represent bugs in your code. So the proper response is to modify the code so they don't occur. Runtime exceptions are called unchecked exceptions because if a method generates such an exception, its declaration does not need to indicate so. The code that produces such an exception does not need to trap it. All other exception subclasses represent anticipated exceptions. These occur at specific predictable points as the result of specific operations. These are called checked exceptions because if a modifier generates such an exception, its declaration must so indicate. The code that can produce such an exception must trap it. The compiler will enforce these rules. When you write code that traps and responds to an exception, you are handling the exception. Java's mechanism for trapping exception is the try structure. The try structure has three parts. First one, the try block itself, containing the code in which exceptions are detected. Second one or more catch block to respond to various types of exceptions. Third one, an optional finally block containing code to be executed even if an execution occurs. The try or catch structure works for all throwables, but not only exceptions. But usually exceptions are the only ones worth trapping since errors are hard to predict.